All right, so one of the things we've been talking about through the layers of the earth is this idea of the crust, the mantle, the outer core, and the inner core. Now, as we go through earth, remember, we've only been into the crust. We've never passed it. People say, well, how in the world do we know that this picture is accurate if we've never? Well, we don't know. We've just inferred based on two things. One, we can study some of the rocks and we can look even at volcanoes. We can say, wow, when the earth is opened at an opening like a volcano, specifically out in the middle of the ocean, we have a great volcano that's constantly erupting right out there off the island of Hawaii. This gives us a lot of information and direct evidence of maybe what's going on just under the crust, as we see that our predictions are it's part of that outer core burning up through the mantle and straight through the crust. We call this a hot spot, is what we call this. Yellowstone National Park is another example of what we would call a hot spot. You're basically in a park, which is a big opening to a volcano, and that's why bubbling water and geysers and all sorts of things, the ground is very hot. We also know that as we go into the crust, deep within, the temperature tends to increase. We call this the geothermal gradient. Geo means earth, thermal means temperature, and a gradient is just an up or down. So as this gradient increases in temperature as we go down, we notice that, wow, the earth gets warmer. In fact, people that go deep within mines tend to feel the temperatures increase. So there's specific things that people who work in mines will have to wear, have to have as equipment just to make sure that their bodies can regulate that temperature, because as you go deeper and deeper into a mine, it's going to get warmer and you're going to probably end up sweating quite a bit. As we go into the earth, it gets hotter. It gets warmer. The temperature increases. So we start to infer, boy, I think it gets warmer and warmer and warmer as we go down. We must have then a really warm inner core, outer core, and even the mantle on top of the crust. Now, the thing about it is, we've got these things called convection cycles.
It happens because hot rock rises, heated by the Earth's core.
We're thinking that as that liquid outer core is heated up and expands, it moves up through the mantle like this. And as it moves up through the mantle, it reaches the crust. As it reaches the crust, sometimes it can burn through the crust, but sometimes it doesn't. We're thinking it moves across under the crust and begins to pull that crust along the earth. Now, there are cracks in the crust. When we look at plate tectonics, we look at the cracks found within the crust. In fact, there's a map that shows all the different cracks that we can see within the crust. We're thinking that this liquid, as it moves up through the mantle and as it moves with the crust, pushes slowly that crust along. We also think that as that crust maybe reaches what's maybe a ocean crust, so the bottom of the ocean, which is very thick and dense, we're thinking that as that reaches the continent, the places above the ocean, and runs into it, because that ocean is so dense, it's so heavy, it moves down below the continental crust. And as it moves down below, well, then we get into something which is really crazy. We get into something that we call a subduction zone, where it's subducting, meaning going underneath. And in this area right here, let's take a look at this, because this is kind of an interesting area of our diagram right here when you really think about it. I'm going to zoom in just a little bit more. Let's see if we can. In this diagram, we see two things right here that are happening. Actually, three if you consider this. Right here, off of the edge, there is a little area where it looks like right through the crust is this plume of magma, which is melted rock inside the earth, magma burning through the crust. And as it's burning through, you can see some of this magma is moving this way and some of this magma is moving this way. And what we're actually creating is something called a divergent boundary. A divergent boundary. Let's look at what that one looks at. A divergent boundary, like this one here, is found all over the earth. In fact, right down the middle of the Atlantic Ocean, we have divergent boundaries where the earth is splitting apart and new lava is coming up through the middle. We also have this off the coast where we live on the west coast of America, right off of Seattle. So here's an example of a divergent boundary. And what happens is, slowly over time, it's going to push apart that crust. And you can see the directional arrows here show you the direction that these two plates are moving as the lava. Let's go in reverse. Let's do it again. Over time, up through the middle comes the magma. And as it comes up, it pushes in different directions these plates. And you see them moving in different directions. There it is. But wait a second, Mr. Jensen. If this plate moves this way and it crashes into this big old mountain right here, what's going to happen to it? Well, we're predicting that it actually goes down underneath and creates trenches in some areas. Now, how do you know it goes down? Well, we've actually studied subduction zones. We've gone underneath the water and we've looked at some areas where this has happened, specifically after earthquakes occur. We've seen this off the coast of Indonesia. We looked as what happened was the bottom of the ocean went underneath another part of the ocean. And we watched it as literally this massive tsunami occurred in 2004. We also went down to the bottom of the ocean and saw where the land had lifted up on the bottom of the ocean and the other one had gone underneath it. And it blew scientists away because it was direct evidence that this is actually what is going on in some of these areas. And so as this plate moves underneath this continental plate, which is much thicker, going up, this is a heavier plate going down underneath. All the compaction of the material inside of it makes it more dense. As it moves down, now we have a whole nother scenario. So again, here is where we've got what we call divergent. They're moving away. Kind of reminds me of the book Divergent, where she's trying to get away. Divergent, moving away. And then it moves into the continental and what we call a convergent. You converge. You converge. And in this area, it's coming into itself. And so in a convergent boundary, like this one, we have a whole different scenario. We now have a plate moving into land. And as this plate gets pulled underneath, it gets reheated by all this hot magma, which causes it to melt. And pretty soon you've got hot magma, mostly because there's water packed inside of it. And water tends to heat up much faster than the land. So what happens in this scenario is the water adds that steam and gas, builds up and creates a higher melting temperature quicker. And so as you get this happening, it's pulling down that oceanic plate. It's remelting it at a quicker rate and it's sending it up through. And this is where we get volcanoes spewing out lava, much like Mount St. Helens did. And there it is, pushing underneath like this. A convergent boundary. Convergent boundary. And then, weirdly enough, we actually can have a scenario where on land, we might have something move and create a convergent boundary. Maybe this entire piece of land is moving in this direction here. And as it is, it's converging into land. This happens when India is crashing into the continent. There's a place called the Himalaya Mountains, which are these really tall mountains. In fact, you might have heard of Mount Everest before, Mount Everest being the tallest mountain in that area. The Himalayas are interesting because even in the Himalayas, we see seashells on them. And our prediction is maybe that land was lower to where water was covering it, but now it's been pushed up over time. And so up, up, up it goes, creating mountains like the Himalayas. Pushing itself in on land, you're going to expand the mountains. On the ocean, though, it's going to be different because you're going to sink down and you're going to create volcanoes. If it's two pieces of land, though, then you're going to have a crashing through like that. There is one more type of boundary, and this is called a transform, which is when side by side you see land swiping next to itself. And so that's where you get something like this, to where this land is moving in this direction. And so at a transform boundary, you're going to get land moving in that direction. That's another type of boundary that we see, specifically down in California. That's on land where we see some transform boundaries creating a lot of earthquakes as well. As we study volcanoes and earthquakes, we're going to come a lot over this stuff, and we're going to come back to this stuff because these boundaries are where we see this happening. This is where earthquakes and volcanoes happen, is on the edges of the crust that are broken apart. But what creates all this thing? Why does this all do this? It all comes back to the convection cycles that are moving the Earth's crust. There we go.